Our lesson on 1.6 involves solving linear inequalities. Now we've solved linear equations before on 1.3, but the difference today is that now instead of having equations, we're going to have inequalities, which are greater than or less than problems. So first of all, I need you to remember which ones are which. A less than symbol, I always think of it looking like a little L that's been squished. So if it doesn't look like an L, then it's the other way, and it's a greater than. They can also be equal to if they put bars underneath it. We'll talk about what that means. Something to remember about inequalities is that when you multiply or divide by a negative number, you need to remember to flip your inequality sign. So it goes from a greater to a less than, or a less than to a greater than. Now something that maybe you haven't seen yet is instead of using open and closed circles, here in Algebra 2, we want you to use either parentheses or brackets. Parentheses are for greater than and less than. Brackets are for greater than or equal to, or less than or equal to. Brackets mean that you include the endpoint. So it's like a closed circle. It's just a little more advanced than a closed circle. So let's look first at the example x is less than 3. What I want you to do first is somewhere on your number line, write a 3. And since I want to shade everything less than the 3, I'm going to be shading everything this way. Now, here's the tricky part. Because it's less than, not equal to, we're going to have to use a parenthesis, and you're going to use the parenthesis that hugs your shading. So you have to kind of think about where you're shading before you draw your parenthesis in. Now, if I'm trying to graph x is greater than or equal to negative 2, I'm going to put negative 2 somewhere in my graph. I don't need you to label anything else because I know you can count. And this time, because it's equal to, I need you to use a bracket. Now, because I want to shade everything greater than negative 2, I got to use the kind of bracket that would hug all my shadings. So that's how I want you to write them for the graph. Now, I also need you to be able to write your answers as intervals, telling me where all the solutions are. Well, it's kind of hard to list out every single number that will work because there's many, many, many numbers that will work. Anything smaller than 3 in this case would be an acceptable solution. So our interval goes from negative infinity all the way up to 3. And then notice there are parentheses on both the negative infinity and the 3 simply because you can't actually land on negative infinity. And remember, we already had a parenthesis on the 3. Now when I'm trying to write the solution interval for the next example, it starts at negative 2 because that's the smallest value that will work. And notice I put a bracket on negative 2. Well, I got to list out every single number all the way up to as big as the world will let me. So instead of listing them out, I'm just going to write positive infinity. Again, infinity always has a parenthesis on it because you can't actually ever land on infinity. So that's how we write the solutions. Okay, number 1 on the next section has a little bit of work they need us to do. So first thing I'm going to do is add the 8 to both sides. I get 5y is less than 20. And then if I divide both sides by a 5, I get y is less than 4. So I'm going to draw 4 somewhere on the graph. I want to shade everything smaller than 4 because it's less than. And because it's not equal to, I have to use a parenthesis that hugs my shading. Now for the interval of the solution, it's got to read left to right or smallest to greatest. So it goes from negative infinity up to 4. Both of them have parentheses. Okay, number 2, I'm going to subtract the 5 from both sides and get negative 2x greater than or equal to 22. And if I divide both sides by a negative 2, there's something I got to remember. When you divide by a negative number, you need to flip your symbol. So I need to shade everything that is less than or equal to negative 11. So I'm going to draw negative 11 somewhere here. Everything less than him will be down this way. And then because it's equal to this time, we got a bracket. Now for my interval on that problem, he starts off at negative infinity, and then he'll travel all the way up to negative 11, but this time because he actually could land on negative 11, we're going to put a bracket. Okay, and then on number 3, we're going to add the 7 to both sides. So 3 halves x greater than 9. And then I'm going to multiply both sides by 2/3. That's the best way to get rid of the fraction. So if I multiply this by 2/3, I end up with x is greater than 6. So here's 6. I'm going to shade everything greater than him. And then because it's not equal to, I need to put a parenthesis around that. So my interval for that solution would be 6 up to infinity, parenthesis. Okay, moving along. Oh, can't see my problem. It says 2x plus 1 is less than 6x minus 1. Now, I know normally you guys would subtract the 2x from both sides, but when you're dealing with inequalities, you really want to keep the x's on the left-hand side. So I'm going to go ahead and subtract the 6x over, and that's going to give me a negative 4x. And I'm going to go ahead and subtract the 1, so less than negative 2. When I divide both sides by a negative 4, I have to remember to flip the sign because I divided by a negative. 2 divided by 4 is going to give me a 1/2. Now, I don't really care where you draw the 1/2, but I do want you to make sure you shade greater than him. And because it's not equal to, we need a parenthesis. So your solution for that is going to be parenthesis 1/2 up to infinity. Okay, be careful on number 5. We have to distribute the 4. So we get 5 minus 5x greater than or equal to 12 minus 4x. Again, I'm always going to bring the x's to the left-hand side. So let's see here. That gives us a negative x greater than or equal to 7. So when I divide both sides by a negative 1, I got to remember to flip the negative. So x is less than or equal to negative 7. So here's negative 7. I'm going to shade everything less than him. And then I got a bracket because it's equal to. So when I go to write my interval solution for this problem, I got to start way down at negative infinity. And all my solutions go all the way up to negative 7. And we got a bracket. Alright, the next problem, we're going to subtract 7n from both sides. We have negative 8n less than or equal to, when I subtract 6, let's see, I get a negative 2. Divide both sides by a negative 8, and we got to remember to flip our sign again. N greater than or equal to 1/4. So I don't care where you put the 1/4, as long as you remember to shade greater than him. And then equal to means we've got a bar. So our interval solution is everything from 1/4 up to infinity. I kind of find it easier to write the interval solution once I have the graph. I'm a more visual person, so the graph really helps me. Whoops. Moving on. Compound inequalities. So we have keywords here. If you have an and or an or, you're going to see a different type of problem. An and is a really restrictive problem. And means that both situations have to be true. It's kind of like if your parents told you you have to keep straight A's and you need to work 40 hours per week. That would be a very restrictive statement. Or it'd be non-restrictive, where either one of the scenarios can be true. So if your parents said you either have to work 40 hours per week or you have to get straight A's, that would be a little more manageable and it's less restrictive. So what I want you to think about first is what and problems will generally look like. And I gave you an example. Negative 2 less than or equal to x less than 1. That means I need to find numbers that are both greater than or equal to negative 2 and numbers that are less than 1. So on a number line, anything bigger than a negative 2 would be from here, but then it also has to be less than 1. So it would be anything in between there. So when you go to graph and problems, they're generally going to look like, and I'm just going to use parentheses as a generic case here, where you shade in between two numbers. Now, when we graph or problems, generally, and not always, they're going to look the opposite. So the case I gave you here is I want my numbers that are either less than or equal to negative 3, or numbers that are greater than 1. So less than or equal to negative 3 would be here, or anything bigger than 1 would be here. So in general, when you graph ands and ors, the ors are going to look like this, where they kind of shade off to the sides. So this first problem, and I can't see it, is written as what I call a sandwich problem. This is called a compound inequality that is an and inequality. And the way we're going to solve it is it's really two problems in one. So I know if I look in the middle and I tried to solve for t, I would solve for t by adding 8. Now the trick here is we're going to add 8 to everybody. The left, the right, and the middle. So you end up with 6 less than or equal to 3t less than or equal to 18. And now if I look in the middle to solve for t, I would go ahead and divide by 3. So I'm going to do that everywhere. So I get 2 less than or equal to t less than or equal to 6. That means I want to graph all my numbers that are between 2 and 6. And if you notice, they both have equal to bars on them. So we're going to put brackets. So I'm going to say this is 2, 3, 4, 5, 6. Bracket, bracket. And since it's an and, because it's a sandwich problem, we're going to shade in the middle. Now for my interval solutions here, it starts at 2, and it travels up to 6, and they both have brackets on them. So that's how you write your interval. Let's look at number 9. It's another and problem because it's written as a sandwich. So we're going to go ahead and add 3 to everybody. So let's see, we have negative 9 less than or equal to 3x less than, careful, 18. And then if I divide everybody by a 3, I get negative 3 less than or equal to x less than 6. The reason I told you to be careful a minute ago is because this lower bound has a bracket and this upper bound has a parenthesis. Now I don't have enough lines to make this work, so I'm just going to kind of fudge this. I'm going to say this is a negative 3 and I'm going to say this is a 6. So we've got a bracket on the negative 3 and a parenthesis on the 6, and because it's an and, we're going to shade in between them because I need an interval between these to be true. So my interval solution is negative 3 to 6, but negative 3 has a bracket and 6 has a parenthesis. Number 10 should be a piece of cake now. We're just going to subtract 4 on every side. So I have a negative 13 less than t less than 6. And again, I don't have enough lines, so I'm just going to fudge this. Say negative 13, and I'm going to say here's a 6. And everybody is a parenthesis because they're not equal to. And since it's an and, you're going to shade in between. So my interval here is negative 13 to 6. Now I know that looks like an ordered pair, and in math sometimes things look very similar to something else, so you have to use the context of the problem to realize what was your reader really supposed to interpret here. Okay, the next 3 problems are obviously ors because they have the word or in them. There's no shorthand way to write an or problem. So we're just going to have to solve 2 problems at the same time. So I'm going to solve this first one. I'm going to subtract 3 from both sides and get 2x less than 2, and then I'll divide by 2, so x is less than 1. Or I'm going to add 7 here. 4x is greater than 16, and then when I divide by 4, I get x is greater than 4. So I'm going to graph all my numbers that are less than 1 or any number that's greater than 4. So let's say here's a 1, and here's a 4, and if I want everything less than 1, not equal to, I'm going to shade it like that. And then greater than 4 will be above this. So remember, ors are not restrictive, so they don't have to both be true. It's either one or the other. Now the interval for ors is a little more complicated. I start here on the left and I say I go from negative infinity up to 1. Now here's the weird part. I jump over a huge chunk in the middle. So I'm going to signify that by putting a U, which is a union symbol. And then it picks up again at 4 with a parenthesis. And then it goes up to infinity. So the interval for my solutions are negative infinity to 1, union 4 to infinity. Okay, 12, we're going to do the same thing. We're going to solve for the 2 problems individually. So we have 6x less than or equal to negative 6. So x is less than or equal to negative 1. We do not flip our sign there because we didn't divide by the negative. Or 3x greater than or equal to 21. X greater than or equal to 7. So let's see here. Negative, I'm going to have to fudge this a little bit. So we got negative 1 here. Let's say we have 7 here. I want everything less than or equal to negative 1. There we go. And greater than or equal to 7. So when I go to write my interval solution, I'm going to have to move this down here. I've got negative infinity to negative 1, bracket on negative 1, and then it jumps over a whole bunch of stuff. Whoops, should be a bracket. And then it picks up again at 7 with a bracket all the way to infinity. Okay, and 13, our last problem, just same thing, solve them both. We're going to subtract the 7. We get negative 2x less than or equal to negative 4. Now careful, here you are dividing by a negative, so we're going to have to flip this sign. X is greater than or equal to 2. Or 3x less than negative 3. X is less than negative 1. So we've got a negative 1. And then we've got a 0, 1, 2. So I want everything greater than a 2 or equal to, so that's why I used a bracket. And everything less than, but not equal to, a 1. Okay, so writing our interval for this solution goes from negative infinity up to negative 1 with a parenthesis, and then it jumps all the way up to 2 and goes forever to infinity. All right, that concludes our lesson on 1.6, graphing inequalities and solving inequalities.